though. The first thing you'll say though, this is sine squared squared. What is sine squared? What is sine squared? Not sine 2a. Here's the 2 here. Sine squared a is what? 1 minus cosine 2a. So this is what? 1 minus cosine 2x all over 2 squared. You have to do some algebra, I'm sorry. You have to square it. You have to FOIL it out. 1/4. What's 1 minus cosine 2x times 1 minus cosine 2x? 1 minus 2 cosine 2x plus cosine squared 2x dx. And now what do? You have to do this again. Because you got squares, not 2's here. So we'll have to do this again. What do I write here? 1 plus cosine 4x all over 2 and integrated. I'm not going to finish it. You can give it to your calculus one friend if you don't know. That's the end of that.
Oh, yeah. Just the way I did it.
I thought it was just making it more complicated, but no, that's what I did.
I just didn't.
Okay, we'll take a 5-minute break.
I didn't do the square.
You didn't have the square in the last portion?
I just plug it in with A, like I just thought of it. I thought of it. I guess it's not how it's very.
Yeah, playing with science because this shit is not my issue. But he explains it really well.
Yeah, it does.
I feel like I learned how to trade today.
It's been a while since I've ever done
thing we want to integrate. Oh, these things. Now these are powers. Please be assured that these are powers and not numbered multiplicative. Now we know that the derivative of tangent is secant squared. And that the derivative of secant is secant x tangent x. And, and that 1 plus tangent squared is secant squared. And that 1 plus cotangent squared is equal to cotecant squared. So you're going to have to use those. Of course, it will also depend on, because when you differentiate the tangent, you will get the secant squared. And when you differentiate the secant, you will get secant tangent. So it will depend on the powers here, whether they are odd or even. So there are again 3 cases. The first case is n is even. Miss Heather, u is tangent x. The second case is if n is odd and m is odd. Miss Heather? Secant x. The third case is what, Mr. Breda?
Let's see, m is even.
Huh?
M is even.
Well, it could be here.
Both are even.
What is the case we have not considered?
Yes, both.
Huh?
Yeah, both are even, or.
Both are
yeah.
even in this case.
Oh, okay. M is odd, or M is even and N is odd.
So what? Say it again?
M is even and N is odd.
Correct. N is odd and M is even. Ms. Heather, what will you do there? You'll have to come and ask Dr. J. It involves some serious trig and some serious algebra. I really don't want to go astray. Just leave it alone. Leave it alone. Expert. Is somebody who's good with algebra
Do some trapezoidal world there.
and good with trig. You're going to have to do some fancy tricks. What I call arcane tricks. So this lead us astray. I'm not going to do that case. You can go look in your textbook. There's some fancy examples there. Okay, so let's look at these two cases. Let's do one where. So here's one. So this is n is even. So let's say we have secant squared x, tangent squared x. That would be the first case. So we're going to make the substitution what? U is equal to? U is equal to tangent x. And so we'll need the derivative. What is the derivative?